Hey, good morning, everybody. Aloha. Hope you're doing well, staying dry. Hope you got your bike out of the backyard so it's not getting rained on. My son left his skateboard outside. Uh, Hope everybody's doing well. Yeah, we're getting some rain. It's spreading out a little bit. We're not getting it all at once. So, knock, knock. Although we've had some trees fall down in the county. I saw one in Guerneville, a house almost got cut in half by a tree. It fell right through and crushed it. No one was hurt. Uh, but yeah, I think so far no floods. Knock knock. Right? That's cool. And our code numbers keep coming down a little bit more. I think we're down to. I think the average this morning I figured out for the last 7 days is 193. Heading in the right direction. I like that. Under 200. First time in a long time. Okay, you know the drill. Copy this down. Go try it. Come back and see how you did. Okay, we'll see you in a little bit. All right, a little bit is up. 54 and 15. What two numbers have a product of 54 and a sum of 15? That's going to be 9 times 6, or 6 times 9. 9 plus 6, 6 plus 9, right? Remember that word that says you can do that either way, frontwards or backwards? Any order means it's commutative. Multiplying and adding are commutative, subtracting and dividing are not. Okay, 5 and 4 tenths, 4 and 7 tenths. This is a tough one, huh? I'll bet I stumped most of you with this one. If you got this one, pat yourself on the back, because this is a tough one, I think. I did 2 and 2 and 7 tenths. 2 plus 2 and 7 tenths is 4 and 7 tenths. When I multiply 2 times 7, 2 times 27 is 54. But in order to pretend that was a 27, I had to move the decimal over one spot to the right. So I have to move the decimal one spot to the left of my answer. Pretty cool, huh? I stump you on this one too. If you do these warm-ups every day, I will no longer stump you on some of these because you'll get used to the way I'm asking these questions and the types of questions, right? So if you don't get something, remember, you got to add that Y. It's not the IDK, I don't know. It's the IDKY, I don't know yet, right? And then when you're done, and it should bug you a little bit if you don't know yet, right? It should be like a pebble in your shoe on a hike, right? It bugs you, and every step you say, I can't wait to figure out how this works, right? So you should definitely come back after doing the warm up and see what the answer is and see how it worked. So if you get another one like it again, the next time you're more likely to get it right. Okay. That's the whole get. Okay. So 8 tenths and one more tenth is a total of 9 tenths. 8 times 1 is 8. But I had to move this over one spot to pretend it was an 8, and this decimal over one spot to pretend it was a 1. So I have to go back both of those spots in my answer. And what do we say there? Fill in the egg carton. It becomes 800s. 4.5, 4.5. Did Mr. Dan make a mistake? That's usually a good bet. Okay, but not this time. This time I actually have my coffee, and I think I have the answer for you on this one. This is 3, and one more is 4.5 is 1/2. 3 plus 1.5 is 4.5. Now, when I go multiply this, I can, and again, there's plenty of things about this book I don't like, but I like how they teach you one way of multiplying mixed numbers. This is going to be 3 times 1 and 1/2 is to use the generic rectangle. 3 times 1 is 3. 3 times 1/2 is 3/2, which is improper, right? I'm going to use 2 of those 2's to make one whole, which is 1 and 1/2. Okay, see how that works? Okay, very cool. I'm pretty sure I stumped you on that one. So I probably stumped most of you on at least 2 of these. We've had enough of these that you're probably getting them, and I think a lot of people are starting to get that. Okay, exponents. Now, a lot of these are to the third power. You know how there's another way of saying to the second power, right? Instead of saying 4 to the second power, you can say 4 squared, right? And do you remember why that works? Well, what is 4 squared? 4 times 4 is 16. If you had a square that was 4 wide and 4 tall, let's draw the lines. That's 4 rows and 4 columns. How many squares are going to be in the middle? 4 times 4, 16. So something to the second power is like the area of a square. So we call it squared. Now, when we start getting three-dimensional shapes, what's the three-dimensional example of a square? Well, it's a cube, right? Let's pretend like I got a cube here, and it's not just too wide and too tall. There's no such thing as being too tall, Mr. Daniel. Sorry, is it too early for a dad joke? All right, but it's also too deep, right? It has depth. It has three dimensions, right? And if I want to find out how many little of these, that's one block in that corner, right? How many of these little blocks or cubes it takes to make one of these, it's a cube that's too wide, too tall, and too deep. It is, see that top layer? There's 4 of them, right? And then there's a bottom layer. It's going to be 4 more. So that's going to be 8. Well, what is that? That's 2. All right, these are 2's all the way around. Times 2 times 2, which is 2 to the third power. So instead of saying to the third power, when you have an exponent, to the third power, you can say cubed. One word. Kind of cool, huh? Learn a new word. Now you know what squared means, and now you know what cubed means. 3 cubed, if I made one of these blocks that was 3 by 3 by 3, that top layer would be 3 times 3. That's 9, but I'd have 9 in 3 different layers. So that ends up being 27. 3 times 3 times 3. If I wanted to make one that was 4 by 4 by 4, it's 4 times 4 times 4. That is 16 times 4, which is 64. How about 5 to the right? 5 times 5 is 25. 5 layers of 25 is 125. These are getting big fast. 6 times 6 times 6 is 36 times 6. That ends up being 216. Back to the easy one. 2 cubed is 8. 4 cubed. Uh-oh. Giving you a free one, huh? We already did that. 7 squared. Uh-oh. Easy. Not 14. 49. Now 49 times 7 is almost 7 times 50, right? Okay, well, that's 350. How much less is that? Well, it's 1 less. So 7 times 50 minus 7 times 1. 7 cubed is 343. 8 squared, 8 times 8 fell on the floor. I picked it up. It was what? 64. And 64 times 8 is 8 60s, which is 480. And 8 fours, which is 32. And if you can hold that 480 in your head long enough to figure out you're going to have to add a 32 to it, then you get 512. Okay? 8 cubed is 512. So if I wanted to make one of these little blocks, and I got a bunch of little blocks, right? It takes me 8 of them to make a 2 by 2 cube, 2 by 2 by 2, right? I want to make one that's 8 tall and 8 wide. I need 512 of those blocks. Right? It gets big fast. All right. Geometry. Okay. One part of geometry that you have to learn is just the language. You got to learn the names, right? I got to learn the names for all the kids in my classes. You got to learn the names of the shapes. And if there are 3 sides, tri means 3. That's going to be a triangle. If there are 4 sides, 1, 2, 3, 4, it's not a quad angle. It's a quadrilateral. Lateral just means sides. Bilateral means there's 2 sides, right? Now, what if there are 5 sides? Now we get into what means 5. Pent means 5. And we say agon. What does agon mean? Agon means angle. Okay, if something has 5 sides, it's going to have 5 angles. Pentagon has 5. Now, this one has 6. That's going to be a hexagon. And I skipped 7, and I drew a stop sign. Every stop sign has 8 sides. Every octopus has 8 legs. So, oct, agon. is 8 sides, right? So if you learn oct means 8, hex means 6, pent means 5, quad means 4, tri means 3, okay? It'll help you learn these words, right? Now, our decimal system means every time you get to 10, you grab another you grab another digit, right? All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it goes to another digit. 10 tens gets another digit. 100, 10 hundreds gets another digit. 1,000, right? Decimal, a decade, 10 years. A decimeter, tenth of a meter. A decameter, 10 meters. All right, decagon, 10 sides. And we will discuss later why DEC, December, is the 12th, not the 10th month, and why October 8 is not the 8th month, it's the 10th month. Yeah. The Caesars ruined it for us. All right, now what are these things? Okay, well, those arrows signify that they're going to keep on going forever. This line's going to keep going forever in that direction, way off the page, as far as you can see, forever, never stops. Same thing. That is technically what a line is. Okay, this that has an endpoint, we've been calling that a line since first grade. But technically, that's not a line. That's a piece of a line. And we call that a line segment. Okay? Oftentimes, it's still going to get called a line, but technically, that's a piece of a line, so it's a line segment. Now, how about if it has an endpoint here and goes forever in that direction, or an endpoint here goes forever in that direction? If it goes forever in one direction, but has an endpoint, it's called a ray. Okay, and I think of what is a sun's ray? Well, a sun's ray starts from the sun and goes forever, right, until it hits something, right? But in space, it would go forever. Okay, and I always think of a Martian shooting at you with a gun. They don't have bullets; they got one of those ray guns, right? Right. So that helps me remember what a ray is. Okay, hopefully that'll help you too. Again, all of this geometry that we've learned in today is all about language. Okay, learning vocabulary. So this is a great thing that you want to copy somewhere in your composition book, okay? Something you want to have for reference, geometry or vocabulary. Have those written down somewhere. You can look at them every once in a while when you're bored, cable's out or you're done with Netflix. Yeah, I think that's one of my favorite COVID-19 shelter-in-place jokes as I finished Netflix. Can you imagine watching everything they have? Okay, back to math. I used a generic rectangle to multiply. So 4 1/5 and 3 2/3. What do I mean by that? We usually go with digits, right? Ones place, tens place, and everything. But here we're going to go 4 1/5 and 3 2/3. Okay, 3 times 4, that's easy. When I multiply fractions is easy. 2/3 times 1/5. Remember, multiplying fractions is easy. All right. Why? Because you don't have to worry about denominators. You go straight across the top, 2 times 1, straight across the bottom, 3 times 5. You're done, right? But 3 times 1/5, 3 is not a fraction, right? It's easy to turn it into a fraction. You could turn any whole number into a fraction just by putting a 1 under it. That's 3 whole pizzas, right? 3 times 1 on top, 1 times 5 at the bottom. How hard was that? Same thing here. 4 times 2/3 is the same as 4 over 1 times 2 over 3. 8 over 3, 8/3. Let's go ahead and fix that in proper. Divide the bottom into the top. 3/3 can go into that twice. That's 6/3, right? 6/3 is 2 whole. 6 from 8 means I'm going to have 2 left over. Now, if that was confusing, let's just do it in the back real quick and show you what I sort of did in my head. Divide the bottom into the top. Okay, 3 goes into 8 twice. 3 times 2 is 6. My remainder goes on top. What was on the bottom when I started? Okay, 2 2/3. Okay, so the reason I have that 2 2/3 there is now I can just add the whole numbers. 12 and 2 is 14. But now I have to add 3/5, 2/3, and 2/15. 3/5, 2/3, and 2/15. Now, what number do all these go into? I could do it in groups, but check it out. 5 and 3 both go into 15s. I'm going to go 15ths here. The 2/15 is already done for us. For 2/3, how many 15ths? Well, what did I do to the 3 to make it 15? I had to multiply by 5, right? Do the same thing on the top, 2 times 5. And what did I do to the 5 to make it 15? I had to multiply by 3, so do the same thing on the top, 3 times 3. So I have 9 of these things plus 10 more, that's 19, plus 2 more, that ends up being 21/15. That's improper, right? 15/15 is another whole, so I'm going to use 15/15 to carry over there, make that 15. And if I use 15 of them, I have 6 left. And I'm almost done, but I can simplify. 3 goes into the top and bottom, right? So 3 goes into 6 twice, and 3 goes into 15 5 times. 15 and 2/5. Okay? Now, as hard as that was, multiply mixed numbers, we did it in little steps. 15 and 2/5. 4 and 1/5, 3 and 2/3. The other way of doing this that I used to teach was to go ahead and change these using that C method into fractions. Because multiplying fractions is what? Yeah, easy. And how do we do that? Remember, you multiply, then you add. So 4 times 5 is 20 plus 1, 21 over 5. 3 times 3 is 9 plus 2 is 11 over 3. Now multiply across the top, across the bottom. The bottom's easy. That top, I got to go 11 times 21. You kidding me? Yeah. This is why I like that generic rectangle. Because I got this 231/15. Huh? Now I got to divide the bottom into the top, and I'm dividing with 15 out here? That's hard, huh? 15 goes into 23 once. And 15 goes into 81 5 times, because that's 5 tens is 50, 5 fives is 25, that's 75. And your remainder goes on top. What was outside goes. All right, now I got to simplify. 15 and 6/15. We already figured out that's 15 and 2/5. I don't know which way is easier. Either way, that's kind of a tough problem. Let's multiply mixed numbers, huh? Okay. Now, this next one, 8% of 150. You have to ask yourself, what does of mean in math? And if you remember, you're supposed to do this. Now, can I write this as a decimal? Yeah, 8%. Move it over twice. So this is 0.08 times 150. Pretend there's no decimal. Multiply. And then I have...
Veronica, can you please go to E109?
You guys, does that make you think of school? All right, but I got to go back 2 spots in my answer. So, because I moved this over twice to make that an 8. So, boom, boom. 8% of 150 is 12. All right, long warm up for you today, but a lot to explain. Hopefully you did well. I will see you soon. Have a great Thursday.